Measures of dispersion. To interpret data and draw conclusion, we need to be able to summarize it. Summaries that calculates the middle or average, I'll call it the measures of central tendency. Summaries showing data spread around the average is called measure of dispersion. So central tendency, look at the center, what's going on, that's the mean, median, and mode, and how the data is spread is called the measure of dispersion. Without knowing data spread or how it varies, measures of central tendency, mean, mode, and median may sometimes be misleading. For example, in a residential street, there are 20 homes. The mean value of the homes in that street is $200,000. What does that tell us? Not that much, because what's happened actually, there are 3 homes valued at 1 million, 1 million each, and the other 17 homes value at around 60,000. So the average, if you add 3 of those 1 million plus the 17 of 60,000 and divide by the 20 homes, then you're going to have average of 200,000, but it's kind of misleading because the average of majority is roughly 60,000. Which basketball team has more advantage in terms of height? So we have team 1, they have height in inches 72, 73, and so on. And then team 2 has those heights 67 and so on. 67, 72, and so on. Both team has the same average, the mean is 75. If we add those values and divide by the 5 members, it's 75. And the same median is right in the middle, is 76, right in the middle is 76. So in addition to knowing the center, mean, median, or mode, we also would like to know how the data spreads around the center. So the measure of dispersion spread provides a more complete picture. Measure of dispersion include range, standard deviation, and variance. Variance is nothing else but standard deviation squared. So the range of data is the difference between the largest and the smallest data value in the set. So the range is the largest data value minus the smallest data value. So let's find the range for our team. Team 1 would be the largest minus the smallest, and for team 2 would be the same, the largest value minus the smallest value. And we have the solution right here. So the range for team 1 would be the 78 minus 72, which is the 6. That's the spread. And the range of the team 2 would be the 84 minus 67 is 17. So this is the difference between the largest and the smallest value of the data set. Another way to find the spread of data is to use the standard deviation, a measure based on calculating the distance of the data from the mean. If x is the data value in a set whose mean is mu, then x minus mu is called the x standard deviation from the mean. I'm sorry, not standard. So then x minus mu is called the x deviation from the mean, how far that one data value is from the mean. Now, the standard deviation is we would square those values and then add them. Sum is denote the summation, this add them, and divide by the number of values. We will see on example. Now, if the standard deviation is large, then the data is more spread out. If the standard deviation is small, then the data is closer together, clustered together. For our example 4, find the standard deviation for each team, predict which team will have larger standard deviation, and explain your reasoning. We know that both team average, the mean is 75. So we can predict, since those those members are more closer together, the height is closer together, then the standard deviation would be smaller. Those data is more spread out because the heights are different, then it should have larger standard deviation comparing to those two teams. But let's calculate the standard deviation. So this is the formula. We use the Greek letter sigma. We're gonna add those values. So for team 1, we know that the mean is 75, and we're gonna calculate for each value minus the mean. So we will have it 72 minus the average is 75. So x minus the average is nothing else but the minus 3. So this is the deviation, or how far this particular data is from the average. So that's the deviation from the average. If we put those data, let's try to understand this. If we put those data on the number line, 72, 73, 74, 75, 76, 77, and then we have 78 right here. Then the average is right here. This is the 73, and we can see that the 72 is that the 72 is 1, 2, 3 units below the average. That's why we have minus 3. 70, this is the average 75. The data value of 72 is 3 units below, so that's what this minus 3 represents. Minus would be to the left, positive would be to the right. So this is we call it deviation. We deviate, we are away from the average. So this is minus 3. Now, they ask me here to square it, so we take this minus 3 and square it, and this is equal to 9. And now we repeat for everything. My x is 73, so it would be 73 minus the average. The average is 75. So we will have 73 minus 75, and the value is minus 2. As before, if we look at the data 73, it's negative 2 or 2 to the left. So it's from the average. How far is it? 2 to the left. That's why it's negative 2. Now we square this, negative 2, square it. That gives me value of 4. And then we repeat the process for all the data members. So it's gonna be 76 minus the average, 76 minus 75, that gives me 1. This time 1 is positive, and we can see that the data 76 is 1 unit to the right. When it's positive, we are to the right, positive direction, and this negative would be to the left. So 76 is 1 unit to the right from 75. Now we do 1 square it, which is 1. We repeat this for the next. We need to list all the data. So we have 72, 73, twice 76. So we repeat the same process. 76 minus 75 is 1. 1 squared is 1 as before. Now for 78 minus 75 is 3. 3 squared is 9. So the 78 is 3 units to the right, 1, 2, 3 units to the right from the standard deviation. Now, if we add all those values, we always should get 0, because we should have even number to the left as if the same number to the right, because the average is right in the middle. Well, not necessarily, but the average value. So we should have the spread. So this is minus 3, minus 2 is minus 5, 1 plus 2, 1 is 2, plus 3 is 5. So the total value is 0. Now for the squares, we would add them because that's the summation right here. So we would add them together. So we have 10, 24. So this value is 24. So what we calculated right here we calculated already that summation because S means add them together, Greek letter for summation, and then we have x minus mu, and square it. So we already calculated this is the top part of the standard deviation. Now we're gonna divide by n. N is the number of data set. So to calculate the standard deviation, for the first team, we would have, sorry, I wrote it. So we would have sigma is equal to square root the added numbers. So the added numbers are here. It's 24 divided by the number n, which is how many we have? 1, 2, 3, 4, 5, divided by 5. And thus we can calculate it. So it's square root of 4.8. So this gives me 2.19. So this is the standard deviation for the whole set. Now we do exactly the same for the second team. So we list all the data 67, 62, 60, 76, 76, and 84, and we're gonna calculate this from average. The mu is the average, this is the average. So we have 67 minus 75, and that gives me minus 8. So if we look on the data set, we would put 67 right here, and 67 is 75 units. I'm sorry, from average 75 is 8 units to the left. That would be this minus 8. Now we take minus 8 and square it, which is 64. Then we take the next member, 72, and minus the average. So we have 72 minus 75. That gives me negative 3. Minus 3 squared is 9. Then we have 76 minus 75. That gives me 1. So 1 squared is 1. The same for this. 76 minus 75 is 1. 1 squared is 1. And then we have 84 minus 75. That gives me 9. 9 squared is 156. Oh, I'm sorry, that's my average. 1 squared is 81. 81. And then when I add them all together, I'm getting 156. Also, when we add those ones, we should always get a 0, and we are getting negative 8 and negative 3 is minus 12, minus 11, I'm sorry, and this would be 10 and 1 plus 11, so the value is 0. Then the standard deviation for the whole one would be square root. We take the summation, so this is the sum would be added. This is the summation of those terms. So we have 156 divided by how many members do we have? So we have 1, 2, 3, 4, 5 divided by 5. So this is square root of 31.2, and the standard deviation for the second team is 5.98. As we were predicting, the standard deviation is bigger because this second team has larger spread, right? The spread is larger of the data right here. The spread is larger comparing to this spread. Example 5. Find the mean and standard deviation for the following data. So the mean, we calculate the average, right? Mean would be 5 plus 8 plus 10 plus 2 plus 6. And we divide by 1, 2, 3, 4, 5. We divide by 5. So in that case, I'm getting that the mean is 31 over 5, which is 6.2. That's my mean. So the 6.2 is my mu in that case. So as before, we're gonna go 2 minus 6.2, 2 minus 6.2, That gives me minus 4.2. And here we're gonna square it, 4.2 square it, and I'm getting 17.64. And then we proceed with all the rest. We do the same with the second data. So this is 5. I think we put them in the order. So this is the data 5, this, I'm sorry, 2, 2, 5, and so on. So now we proceed with this, all of them. 5 minus 6.2. So this gives me negative 1.2. Now we do negative 1.2 square it. So this gives me 1.44. And the same 6 minus 6.2. So this gives me minus 0.2. Minus 0.2 square it is 0.04. Then we have 8 minus 6.2. This gives me 1.8. 1.8 square it. This gives me 3.24. And then we have 10 minus 6.2. So this is 3.8. 3.8 square it. This gives me 14.44. And if we add them together, so this equals to 0. And if I add all those values together, pay attention to the decimal. When I add them together, I'm getting 36.8. So then for standard deviation would be square root of the added value, the summation of all the values squared. So this is my 36.8 divided by how many data we have. We have 1, 2, 3, 4, 5 divided by 5. So this is square root of 7.36. So this is 2.71. This is my standard deviation for whole data set. Now, for each data, example 6, for each data set has mean of 50, set A, B, C. By examining the data, predict which set has the greatest standard deviation and which has the least. Calculate the standard deviation. So by examining the data, the largest standard deviation would have the set that has the most spread. So here we have 20, 40, 49, 50, and this is 1, 2, up to 100. So the largest standard deviation would be the biggest spread. So I think the set C should have the largest standard deviation. Now, the closest together would be those ones are very close to 50, except we have 1 or 2 outliers kind of, but those ones are evenly spread. So the smallest standard deviation should have set B because the data is closer together. Then would be set A because it's spread not too far, but the largest standard deviation should be for set C because the data is the most spread. And then we can calculate them together. So as before, my average is 50, so my mu would be 50. So for each set we would go 0 minus 50 is minus 50, 20, 20 minus 50 minus 30, and so on. So if we calculate them for each set, then you square this value, and then standard deviation, you would take the total, divide by the number, how many numbers do you have. So standard deviation for set A is this, for set B is this, and for set C is this. So our prediction was correct. The largest has the set C, that's the largest spread, that's the standard deviation. The smallest has the set B because the middle part is the closest together, so all the set data is close together. And set A is spread evenly, then has those data.